Welcome to Genius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hello, welcome back to our video tutorial program. In this video, you will learn molarity. It is a topic which is found in Senior 3 according to Rwanda Education Board curriculum under Unit 7, Senior 3, Unit 7, Concentration of Solutions. And today we will explain how different solutions, of course, having different molarities, can be prepared using the simulation we have on the platform, www.opanda.xyz. Here we have the objective of the lesson. We should be able to demonstrate using a lab simulation how various solutions having various molarities can be prepared. First of all, let's have a look at the important definitions. What is molarity? Molarity is the amount of solute present in a solution expressed in mole per decimeter cube. Mole per decimeter cube is the same as the unity of concentration, molar concentration, and molar concentration is the one we call molarity. Here we are using the term solution. A solution is a mixture of a solute and a solvent. And in this case, we also have to explain what is a solute, what is a solvent. So a simple mixture contains a single solute and a single solvent. The solute can be solid or it can be a liquid. It can even be a gas. So a solute is that component of the solution which is present in a smaller amount. For example, if you take 2 grams of table salt, mix it with 1 liter of water, the 2 grams, this is the solid particles or the solid component, which is present in a small amount. And this is the liquid which dissolves the solid component. So this one, which is dissolving the other substance present in a small amount, we call it the solvent, and the substance present in a small amount, we call it the solute. Now let's jump and go to the simulation to explain how we can prepare solutions of various molarities using the lab simulation. The simulation we use is this one. You can see here we have a beaker which contains some liquid. It contains a given solution. Here we have some buttons we can use to increase the solution's volume or change the amount of solute. The volume of our solution will be in liters and the amount of solute will be in moles. You can reduce. See, when you reduce, we are used to this color, the color which is light blue. It represents water, water which doesn't contain any solute. So here, by moving this button, you can see you change the color because you are adding a certain solute, a certain amount of solute. Now let's check what happens to the color of the solution when we increase the amount of solute. When the amount of solute is increased, you see we are increasing the amount of solute. How does the color changes? See, the color is becoming darker. That is the first observation we can make. Without going into digital values, we can see that the color is changing. And as the color becomes darker, how does the molarity change? Let's have a look again. Reducing the amount of solute, we are also reducing the concentration, the molarity. Look, we reduce the concentration as we reduce the amount. Remember, the concentration is number of moles per volume. So as we reduce the number of moles, we also reduce the molarity, as well as changing the color. Increasing makes the color darker. Here you can show the values. You see the value we have here. The maximum is 1 mole. So the solution we have is 1 mole. And here we have a half liter. So because you see here the volume is a half liter, then the molarity will be 2 molarity, or 2 mole per decimeter cube. Okay? 2 mole per decimeter cube. What happens now if you reduce the amount of solute? We will check on the value here. We move it down, move it down. As you move it down, you can see even the concentration is decreasing. So the concentration decreases, or the molarity decreases every time you reduce the amount of solute while keeping the amount of volume or the solvent constant. I'm saying that when you change the amount of solute while keeping the volume of solution constant, you get the molarity, which decreases. Now, here we have different solutes. You can change the solute. Copper sulfate, when dissolved in water, we get a blue color. Increasing the solute will also increase the concentration. And here there is something new. Look here. Up to this point, we have a saturation, a point of saturation of our solute. When I increase the amount of solute, look what happens. Now I start to get some solid particles deposited at the bottom. The solute particles, which are in the solid state, are being deposited at the bottom undissolved because the solution has dissolved the maximum amount of solute it can dissolve. And such solutions are called saturated solutions. So a saturated solution is a solution which has dissolved the maximum amount of solute it has dissolved. And using this button, you can change the solutes you are using. You can change the solutes you are using by using this button. As usual, if you click on this one, this icon, you can reset. I click and then we reset. So let's now have a look at what happens when you change the volume of a given solution. Let's say that here we have a solution of copper sulfate. And here we have its concentration, it's 1 molarity. What happens when we increase the volume? Let's have a look. Increasing the volume is decreasing the concentration. We are increasing the volume while keeping the amount of solute constant. And you can see the concentration here is reducing. The molarity is reducing. So when you have a given solution and you think that its concentration is very high, the molarity is very high, to reduce that molarity or the concentration, it is not possible to remove the solute because they have been dissolved. But you can increase the volume. You add more water, for example. And in the same case, if you want to increase the concentration for your solution, there are 2 possible ways. You can increase the number of moles of the solute particles or reduce the volume. You can reduce the volume by evaporation, for example. Okay? And let's have a look. When you change the volume, how does the color change? Reducing the volume. Let's look. You see, As you reduce the volume, we said the concentration increases, and even at a given time, you will start to have a saturated solution. You can see the undissolved particles. So as you reduce the volume, you increase the concentration, and at a given point, some of the solute particles will start to precipitate out of solution. So you get a saturated solution. So this is how we can use our simulation to show how various solutions having various concentrations can be prepared. You can prepare a saturated solution. You can show how you can reduce the concentration of a solution. You can show how you can increase the concentration of solution, either by changing the amount of solute or changing the volume of the solution. How is this concept of molarity useful in our everyday life? Most of the liquid substances we use every day are in the form of solutions. These should have the right molarities for their maximum efficiency. For example, we need to know the right amount of sugar to put in tea to have a perfect taste and avoid risks of excess sugar. You know diabetes and its effects. We need to know if probably you have added a lot of sugar. How can you reduce it? You can't remove it, but the possible thing is to add more tea, okay? And let's take another example. If you are, for example, preparing a hand sanitizer or a liquid soap, you should know the right amount of each component. Add some chemicals such as this alcohol, the alcohol we add, the sodium hydroxide, which is a corrosive substance we also use. These substances can harm the skin. So we have to know the right amount of those substances to be used to produce products which are effective and harmless. And we, of course, need to know how we can adjust the molarities when, for example, they are greater than required or less than required. So these are some of the everyday uses of this molarity concept. Thank you very much for watching. I hope you enjoyed the video. And if you are ready, you can go right to the quiz. And if you think that you are not ready enough to take the quiz, you can replay the video. For those who are ready for the quiz, here is the quiz code VID 001001. And here we have the steps to follow while taking the quiz. You just go to the website opanda.xyz, you click on login, and the login is here. Okay? And next, you go to take a quiz. When you click to take a quiz, the window you will see is this one, and you tap the code and you type the code in here. VID 001001. And then you take the quiz. Thank you very much. See you next time for more videos.